Hello class, this is a video tutorial on the key features of quadratic functions. In the previous video we looked at the key features. We explained a little bit about the concavity, whether it's concave up with a smiley and concave down with a frowny. And we did one example of finding all the key features. We're going to do 3 more examples. You can give this a go yourself. I'll zoom in to each of them so you can pause the video and find each of these key features in the same order. So here we go. So here's the second example. I'll zoom in as much as I can. Here's the third example. And here's the last example. Hope you paused each of them and give it a go yourself to find these 5 key features on your own. So let's do this. Here we go. Let's do this in 3, 2, 1. Here we go. Let's find the y-intercept first. It's very obvious where it is. It's where the y-axis meets or crosses our graph. It's right there. We can clearly see it is at 0, 4. Sorry, 0, negative 4. Let's find our x-intercepts. It's very clear to see where our graph crosses the x-axis along here. We have 2 points, one here and one here. The x value here is negative 1. So our x-intercept is at negative 1, 0. And this next one is at 4, 0. Next key feature we're looking at is concavity. That's very obvious what the concavity is. It's smiling upwards. So this is concave up. Let's now find the next point, the minimum or the maximum. In this case, because it's concave up, we have a minimum value. We can see it approximately here. Okay, and let's figure out what the x value is by drawing a line straight up to the x-axis. And across to the y-axis like this. Well, let's first figure out its x value. Well, in this case, it looks like it's exactly halfway between 1 and 2. So I'm taking a guess that this is at 1.5. So its minimum value is at x, 1.5. And its y value, from the looks of it, once again, it's going up by 0.2. That's negative 6, negative 6.2, negative 6.4. So it's not quite past 6.2. Sorry, it is quite past 6.2. So I'm just going to let it be, let's say, negative 6.25. I don't know. Negative 6.25. It's very close enough. And lastly, we have the axis of symmetry. And that is just the same x value as the max or min. So this is axis of symmetry at x equals 1.5. Let's do this again for the next example. Let's find the y-intercepts. Actually, let's make this a lot easier. So copy, all these points that we need here. Okay, let's find the y-intercept. It's where the graph crosses the y-axis, in this case 0, -8. Our x-intercepts are where the graph crosses the the x-axis. So here's the x-axis, and where the graph crosses them is at -2 and +2. So -2, 0, +2, 0. The concavity of this, concave. The concavity of this is very clear. It's smiling upwards. So this is concave up. Its minimum value, if you take a look, it shares it with a y-intercept, which is perfectly fine. So in this case, the minimum value, it's a lot easier to see in this one, is at 0, -8. Which means the axis of symmetry shares the same x value as the minimum. So it's going to be at x equals 0. One last example here. Let's copy these again. Whoops. Just to get it ready. Let's just delete or erase the bits that we don't need. Okay, let's move and find the y-intercept. In this case, it's right here. We can see it. It's crossing at 0, 0. So x value is 0. My y value is at 0. So my y-intercept is at 0, 0. My x-intercepts is 1 here at -4. So let's write that in. And notice how this y-intercept is sharing with an x-intercept, which is also perfectly fine. So my x-intercept, my second one, is at 0, 0. This is concave. Well, it's concaving downwards. This is concave down. And because it's actually concave down, this is no longer a minimum. It's actually a maximum value. In which case we can see it's a lot clearer in this one. It's at x equals 2 and y is equal to 4. So not my minimum, my maximum is at -2, 4, which is what it was matching here and here. And lastly, the axis of symmetry, it just shares the same x value as the vertex. So it's at x equals -2. So I hope that gave you an insight using these 3 examples on finding the key features of parabola. Hope to see you in the next video. Best of luck.